Thank you, Bill Go and Agi Hirshberg, for inviting me to this meeting. It's a pleasure and an honor to be here. We understand that hereditary pancreatic cancer is an important component of this disease. 10% of patients have familial pancreatic cancer. If we threw away cigarettes, 1/3 of all pancreatic cancer would disappear in the US. So eating well could be multimodal cancer chemoprevention. The things that we do to ourselves, whether it's smoking or eating a lot of steak or eating a lot of bacon or whatever it is, can actually increase significantly the risk of pancreatic cancer, but the opposite, eating the right way and not overeating, will give us protection. So this is one thing that we need to do. Throw away the cigarettes and eat well. 50% of pancreatic cancer will disappear with just those two things. So current therapies, we heard about the elegant surgical approaches that are being used here. We know about Whipple, we know about pylorus preserving procedures. Neoadjuvant radiochemotherapy means a patient presents with a cancer and you give him chemotherapy and you give him radiation therapy. But then the other thing we need to realize is pancreatic cancer is a different beast. The pancreas is a totally different organ from all other organs. There is an intrapancreatic portal circulation. The beta cell lives in the pancreas. The beta cell makes high levels of insulin. The insulin bathes the exocrine cells before it's drained through the pancreatic vein into the liver, where a lot of it is degraded before it goes into the systemic circulation. These high insulin levels can bind and activate the IGF-1 receptor, which is a growth-promoting pro-survival receptor. There's no other tissue in the body that's exposed to such high levels of insulin. This cancer, we need to target KRAS, and we need to find scientists that will understand how to really target KRAS. We need to restore p53 and p16 functions. We need to target the stroma and the stellate cells. And they produce a whole bunch of factors. They produce growth factors, they produce periostin, they allow the cancer cells to migrate, they produce laminin, collagen, fibronectin, and MMP2, all of which allow the cancer cells to be invasive. The other thing, of course, is they form a cocoon, which increase hydrostatic pressures, which prevent all our great cancer drugs from getting into the microenvironment and attacking the cancer cells. So maybe agent XYZ would work, targeting KRAS or targeting EGFR, but we get minuscule amounts to the site of action. The drugs cannot get here. We think there is a ray of hope. We think that we can personalize this therapy now that we understand all these things. And we have to think outside the box. This is Alexander the Great, who was challenged with solving the solution of the Gordian knot. And he said, he took a knife and he cut it. He said, that's it. There's no more knot. That's what we have to do. Thank you very much.